Welcome back, everybody. Today we're talking about chemical kinetics. Now, chemical kinetics is the study of the speed of reactions. And this is an important part of chemistry, especially in biochemistry, which is my area. And in order to study reactions, we have to study how fast they are going because some of them take years and some of them take micro and nanoseconds. As I speak, you have thousands, actually millions of reactions that just happened inside your body. And we have to measure them. And actually, sometimes diseases come from slow reactions. So we study and care so much about speeds of reactions when it comes to proteins, when it comes to drugs, when it comes to metabolism, all of that stuff. That's what metabolism is, right? You've heard of somebody who say they have a slow metabolism versus fast metabolism, where those are chemical reactions. So it's a big, important branch of chemistry, and it can be tedious and it can be a lot. But for today, we want to make it simple. We want to make it straightforward, but I still want to make sure that you know what you're doing and still want to um, teach you how we do these, and then I still want us to do a little bit of calculations, not too much, not too complicated, but I'll make sure that I teach everything that I want you to know when it comes to chemical kinetics. So let's get started. Let us get started. This will allow me. All right, chemical kinetics. So what are chemical kinetics? Chemical kinetics go with how fast does a reaction proceed. So speed of reactions. Um, Thermodynamics have to do with energy. So thermodynamics have to do with energy, and that energy will tell us whether or not a reaction can actually take place. And we'll talk more about that because we will calculate energy in this lab. Um, so the reaction speed, right? The reaction speed that we're going to be measuring, by the way, is going to measure to be measured by the change of concentration in time. Change of concentration of what? It may be change of concentration of the reactants or change of concentration of the products, depending on what we're looking at. All right. So there are things that can affect this rate. What are rate? It's speed. So reaction speed, we call it rate. So there are some terminologies and some terms that we will have to remember, and one of it is rate. The rate of the reaction is the speed of the reaction. So concentration, temperature, catalyst, which are things that can speed up reactions, surface area, right? And then pressure in terms of gas. These are things that can increase the rate or increase the speed of the reaction, right? So kinetics is going to study the rate or speed of reaction, right? And also we can get into something that we call the reaction mechanism, or how does the reaction occur. So this is kind of this is one of the things that kinetics gives us, right? So when it comes to kinetics, again, we have your rate of the reaction, right? So write it down here. Here we go. All right. So when it comes to kinetics, we have, make sure that I can see what I'm writing. There you go. Oh, there you go. All right. So when it comes to kinetics, right? So they say kinetics, right? So I'm just going to make sure that we understand all these terms that we're going to be using, right? Chemical kinetics, the study of chemistry that deals with speeds of reactions, right? And but when we talk about speeds of reactions, what do we actually mean? We mean we call it rate, right? So speed here, I don't know if black is gonna work. Probably not. The red. Yeah. So it deals with speed of reaction, and then we call it rate of the reaction, right? We call it rate of the reaction. That's what kinetics deals with. But in addition to that, right? In addition to that, these rates, as we talked about, are going to be based on what we call rate low. So let's say this is simple. A plus B gives us C, right? As you already know, you have A and B are reactants, C are products. You should know that. Now, the speed of the rate will be either the speed of the disappearance of our reactants or the speed of the appearance of our of our product, and these speeds should be the same, right? So it depends on what we can measure, because it's very hard, by the way, it's very hard to measure the speed, because what if it's just two clear solutions? You add two clear solutions together and then one clear solution emerges. How are you going to measure the speed? So we need to find a way to measure. So we need to find something like that changes color or something like that, right? So that's how we measure the speed. And a speed or rate is measured in concentration per time, right? So it's measured in concentration per time. So concentration per time. So it will be like mole molar per minute or something like that, right? Molarity per minute. That is what the speed is going to be like, right? So molar per minute or something like that. So with that rate, you can measure, again, with the rate, you can measure two things. You can measure either the appearance of the products or the disappearance. So appearance of the product is in math, you don't need too much math, but if you've taken calculus or something like that, you might know. So the change, which is delta, so delta of C over change in time, or dt or something like that, right? So that is our rate. So rate is equal to change in C, or change in product over time, or the disappearance. It's just that you're going to give it negative, because the disappearance will be will the disappearance of our product will go down, so that's why we give it a negative. But the disappearance of our product over time is equal to the change. So the change in, not product by reactant, the change in reactant over time is equal to the change in product over time as well. So this change should be the same. And again, this is the rate, right? This is the rate of the reaction. That's how we set up the rate of the reaction equations. All right. So the problem is that, yeah, you can do that, but it's very hard to calculate a lot of things with this. So let's move this. Wow, okay. It's good. I can even make it smaller. Okay. All right. So the problem with this is like it's good to understand, but it's hard to do calculations with these and understand the actual speeds. So in addition to this, we have something that we call rate low. Rate low. Okay. So go on the other side and then say rate low, right? So every reaction is going to have a rate, or every reaction is going to have a speed. And if a reaction has a speed, we can write down a speed low or a rate low, right? And this is an important number, very, very important number, by the way, that we definitely need to know how to calculate for each equation that I give you. So the rate low is going to, let's say you have an easy reaction, same reaction we talked about, A plus B equals C. The rate low, right, or will be expressed in terms of rate equals, remember, rate our is our speed, right? So the rate or speed is equal to, right, is equal to, it's going to start with K, right? So our rate is going to be equal to K is a constant, right? Rate constant. So this is the relationship between our rate or our speed and our concentration. So it's K, which is a constant, times concentration of A times concentration of B, right? And these will also have numbers at the top, right? So we can give them A and B, right? This is the rate low. This is the rate law for this equation, the rate low. And we need to be able to know how to do that. Why is it important? Is because, again, this is how we're going to relate the speed of our reaction to the concentrations of our entities, right? And this, again, is a constant, right? It is distinct for each reaction, right? So this is going to be rate constant. Nice, right? This is going to be the concentration of one reactant, the concentration of another reactant, and then again, this is the rate. Now, very importantly, the A and the B are, so A and B are orders of reaction. The order of reaction. And these are very important. These are very important because these are going to determine how fast our reaction is going, right? So some people think that these orders of reactions, A and B, are the same as coefficients. No, they're not the same as coefficients. So even if you have like coefficient here and here, they will not transit, right? They will not transit. Sometimes they do, sometimes they don't. But I really want everybody to understand this. I really want everybody to understand this concept of rate laws and orders of reaction. Why does it matter? It's because for every reaction out there, right? For every reaction, we're going to have rate laws and orders of reaction. So if we have like, let's say we have we have like no, I'm trying to find something realistic, but also it's hard to find something that you can measure. But let's say we can, even though we can't. But let's say we do H2 plus O2 is equal to H2O, right? And then you balance it. This reaction, right? We may be like, okay, let's study the rate or the speed of this reaction. Well, the rate low. So I can ask you, give me the rate low of this reaction. So the rate low is going to tell me like rate is equal to K, which is the rate constant, times the concentration of H2, right, times the concentration of O2, right? And then this will be A, B, or M or N, right? So this will be M or N. We cannot get M or N from here, right? We cannot get it from coefficients. How do we get it? Usually we get it from experimentation or calculations, right? So M or N will be our rate orders. Now I want you to see something, right? Let's say M or N are just one. They are both one. If they are both one, K will be equal, rate will be equal to K times H2, right, times O2 or something like that, right? All right, so here's one. But if it's two, for example, right? If it's two, if the rate is two, what's going to happen is going to be the order is two, right? It's going to be like, yeah, you have one here, you have O2 here, then you have two here. If you have two here, what's going to happen to the rate? The rate will be multiplied. The rate will be way more. You see how the rate order affects the rate? It affects the rate over time. So I have a chart right here that kind of puts all of it together here, right? So you have different reactions, right? So you have like a zero order reaction, first order reaction, second order reaction. And depending on what type of reaction you have, it's going to behave different, right? So if it's a zero order reaction, with respect to A, again, you can think of it like that. That means that the rate is equal to K times A to the zero, right? The rate is equal to K times A to the zero. And guess what? A to the zero is 1. So the rate is going to be equal to K. First order reaction, rate is going to be equal to K to the A1, which is first order. Second order reaction, the rate is going to be equal to K to the A1 squared, right? So zero order reaction, first order reaction, second order reaction, and they're going to behave differently. I want you to look at how it happens. So if you take concentration versus time, it's going to be a line. It's going to be linear like this, right? As you increase time, the concentration will decrease exactly the same, or it will increase if you're measuring the product. But you see how it's the same here. But the first order reaction, it decreases but not in a linear way. It decreases faster. And then second order reaction, it decreases even faster. Why? Because again, the rate increases dramatically. The rate of the reaction increases dramatically, right? So why am I saying this, guys? I'm saying this because this is our experiment. This is our experiment. We are going to measure the rate of the reaction. And then after we measure the rate of the reaction, we are going to plot it. You're going to plot it against, with concentration versus time. And then we're also going to plot it with, concentration versus time. And then we're going to plot it with 1 over concentration versus time. and then we're going to plot it with ln of concentration versus time, because it seems like by just doing this, you can tell which type of order our reaction is in just by making a graph of time versus concentration. So that's what I want you to do just in Excel, right? You're going to measure time and concentration, and then you're going to from that and the graphs, you're going to tell me what order of the reaction that is. That's the first part of our experiment, right? You're going to measure that, our first part of our calculations. There is another way to measure the rate order, but we're not going to use it. That's the one at the bottom here. We're not going to use it, so I will not confuse you with that. The way we will measure rate order this time is we're going to measure the time, and then after we measure the time, we're going to measure the concentration over time, right? And then we're going to do we're going to plot concentration, ln of concentration, and 1 over concentration, all versus time. And then we're going to see if these look like either a line or kind of a curved line. If it's a linear line, we'll be able to tell if it's zero order, first order, or second order, right? So we're going to be able to tell. So take this as your reference point. All right, so that's the first thing that we're going to do in our calculations after we do our equation. The second thing that we're going to do is we're going to measure the energy, guys. We're going to measure the energy, which is pretty cool. How are we going to measure the energy? Because look at this. There is this equation called Arrhenius equation, right? Arrhenius equation. It's very important to measure the activation energy of a reaction. The activation energy of a reaction, very important. So we can measure it experimentally if we already measured the rate. Because guess what? If you have the rate, you can give me the rate constant. How? We just looked at it, right? So if you have rate is equal to that, you already have everything. You have the rate order, so you can give me the rate constant very easily, right? So if you have the rate constant, right? If you have the rate constant, so this we have, so let's do it like this. So we have the rate constant. We have the rate constant, right? The frequency factor, this is also a constant that I'm going to give you, right? Guess what? R is also a constant, right? And then the temperature, we're going to have the temperature. And from there, we can get the activation energy. We can get the activation energy. It's pretty cool, right? And, well, this is a bit more complicated, but there's a linear version of it. There's a much easier version of it for calculating this. So we can calculate this by, again, using A, using temperature, using R, then using ln of K to find the activation energy, right? And in fact, another way to experimentally do it, especially we actually going to do it this way because we will use two different temperatures. So if you use two different temperatures, you can use two different temperatures, and then in these two different temperatures, we're going to get two different rates. And then from those two different rates, we're going to use the constants that we get from those, right? And from there, we're going to be able to measure activation energy, right? So again, you're going to measure activation energy. So from today's lab, we should be able to measure the rate, measure the rate constant, and then we're going to do it at two different temperatures so that we can measure the activation energy. Right. So just a very quick overview so that you're not too surprised. We are going to use a cell phone here. For this lab, we're going to use a cell phone. A cell phone is a very it's you can use a cell phone to measure a change in color, and we already know that a change in color can indicate the progress of a reaction. So we're going to, in this case, use food dye, right, which is blue, and then we're going to use bleach. Why? Because bleach actually takes away that color. So if you add food dye and bleach, right, this is a chemical reaction. And the blue dye will go down over time. The blue dye will go down over time. So the blue dye will go down over time. And then guess what? We're going to use a phone app to measure the concentration over time. So you will have a timer and a app that can measure the color. So over time, you're going to measure the disappearance of the color over time. So the disappearance of a color over time will give you the rate, because the rate is just a change in concentration. So you're going to take like a change in concentration over change in time, and that will be your rate. And then after you get the change in concentration over change in time, which is your rate, you're going to do the same using hot water, right? Using a little bit of hot water, you're going to make sure that you measure the temperature of the water, not water, but hot reaction, right? Before and after, you're going to use room temperature reaction and then a hot reaction. And then we're going to measure the disappearance of that color as the bleach turns the dye into a clear solution. And then from there, you're going to measure the rate of the reaction, measure the order of the reaction. And then from there, you're going to measure the activation energy of the reaction from the two readings and two temperatures. All right. So I think that's enough. Hope that's enough. That's enough about kinetics. You should understand what you need to do. You should make sure that you understand, take your time. I know that we did this in lecture, but this was kind of a recap to make sure that you understand what we're going to do. But if you have any questions, make sure that you ask me questions before you get started. But if you are good and ready, let's begin. This lab is going to require a few items. First, you're gonna need some sort of a timer. Keep in mind that you're gonna be using your phone separately as well. After you got a timer or another phone, you also need things like your gloves and goggles. As usual, you're gonna need a beaker, and you're gonna need a red paper right under your beaker. You should have it in your kit. You're also gonna get a ring stand, some sort of a ring stand. So this ring connects to your stand like that. You're gonna need your phone, and then you're gonna need these disposable pipettes and solutions. That's mainly what you're gonna need, and of course your stand. So to get started, of course, as usual, you're gonna put on your goggles and your glasses, and as you can see, we've already assembled the ring stand to be right above your beaker, right? So the ring stand should be right above your beaker, and then the beaker should be right above your red paper on the stand, and you will know why in a minute. So to get started, you should have an app on your phone, and you should have a link to the app. I think it's called Color Name on iPhone, but we will also send you a link for Android. but you should have an app that can identify a color and give you a number for it. It's called color name. So we want an app that changes numbers as you go up in color or go down in color. So you should make sure you set it up, you have it open, and then you set it up so that it can measure our blue color or red color as well. After you have that app set up, you're gonna go ahead and put your phone right above the beaker, making sure that it is right in the middle. Right? It is right in the middle, and it's reading the red color. So it should give you the reading for the red color before you start setting up your reaction. So that's how you set up the reaction. Make sure that you have that your phone is working, it's reading the color, it's changing as the color shifts and all that stuff. And then make sure that you have a timer on the side. And after that, you are ready to continue. To continue, you're going to start a reaction. And to start the reaction, we're going to start with the reaction at the bottom. And the reaction in there is going to be bleach. So we're going to put bleach in there. And the manual, I think, says 10 milliliters. So you're going to add bleach in there, and then you're going to add 1 drop of your reagent. So we're going to add bleach, and then we're going to add 1 drop of your reagent, right? So after you add plenty of bleach to make 10 milliliters, we're going to add the next reagent, because we have 2 reagents, and the next reagent is food coloring. So you're going to add just 1 drop of food coloring. And then this is where you have to be careful, because before you start, you gotta make sure that you time it, and then you have a way, a place to write, because you are going to be recording the time at every 10 seconds. You can do 5 seconds as well. Let's do 5 seconds, but preferably 10 seconds. Another way that I've seen people do it much better is just do a screen recording of their phone. If you do a screen recording of your phone, as the color changes, you're gonna have the data where you're gonna have the time going up along with the reading. So you can do a screen recording, or you can record on your notebook, but go ahead and start the timer. And when you start the timer, you're gonna be like, okay, at time 0 I have this reading, at time 5 seconds I have this reading, 5 seconds I have this reading. So you're gonna be writing down 5 seconds until the color goes away, and don't worry, it won't take too long. So as you can see, we're gonna add the food coloring, mix, and then get started with the timer, get started with that, and then start reading, right? From time 0, then 5 seconds after, then after 5 seconds, right? We keep doing that. And we're gonna keep reading until the color disappears, right? And as you can see, if everything is going well, the color should be going, and that is the reaction we discussed happening in front of your eyes, right? So it's gonna keep going, and I'm gonna let it go so that I can show you how it becomes clear over time, right? And the number should be going down. The number should be going down as you go, right? Up until it's clear and doesn't change anymore, and that will be your last reading. So that is the reaction. That is the reaction. So all you have to do is, after that reaction, you need to do it again, but in a different temperature. So we can heat it up right? We can use hot water. So we will do it two more times. Once using hot water, then once using cold water. So I want you to go ahead and bring hot water. We don't want to we don't want you to get injured. So make sure that you use either water from your tap water that's pretty hot, or microwaved water but not too hot, right? So use hot water and then use ice water. So we will use hot water and then we will use cold water, and then we will do the same thing. So here we're doing it, we're putting water in ice for a while, right, so that it cools down, and then running the reaction again. So we're going to do the reaction at low temperature and then at high temperature, and then we're going to see, and I promise you that you are going to see a big difference. But the most important thing is, since you have a thermometer, I want you to measure the I want you to measure the temperature of the water, the hot water, the cold water, and the room temperature water. Those three temperatures, along with the numbers that you're going to have, will give you plenty of the data to determine everything that we need, right? Because after you're done, remember, we're going to find the reaction rate order in regards to one thing, the reaction order in regards to another, and they're going to find the reaction constant, right? The reaction constant, and then after, we also going to find the activation energy, right? So all this data will give you what you need, and then after you do your three reactions, then you are done. And then after you're done, what are we gonna do? We're gonna make sure that we clean up. You can put this in the sink as long as you make sure that you wash it down. Then you can disassemble your equipment, throw it away, wash it, disassemble your equipment. You can keep the red disk, clean up your desk, and then you should be done with the experiment. Guys, that was chemical kinetics. I hope you enjoyed it. But if you have any questions, feel free to reach out, and I'll see you in the next one. Bye bye.